Hello again. Remember we had talked about water being a wonderful solvent and that we could produce solutions by dissolving materials into water. So let's talk a little bit more about this idea of solutions and one of the ways we measure how much material is dissolved in the water. So once again, solutions are composed of a solvent, right? That's a material that's going to be doing the dissolving. And for biological purposes, water is going to be the solvent we're going to see in virtually every case. And then we have solutes, which are the materials dissolved in the water. And one of the ways that we describe the amount of solute dissolved in water is by using a quality called a mole. All right? Just think of it as one way to describe the concentration of a solution. All right? And you'll usually see it as the number of moles of a substance dissolved in a liter of solution or a liter of solvent. Okay? So I just want to expose you to this idea of a mole. You're going to find that we're going to talk about it at a far lower level of detail than you will when you take a chemistry class. But you're going to see the quality of mole. You're going to see the quality of molarity talked about in a couple different places. And I just wanted you to be aware of what that term means. Remember, we're really just talking about a way of describing the concentration of a solute, the concentration of some material that's in a solvent. Okay, so let's take a look at some examples of this idea of a mole. When I take moles and I dissolve them in solution, we're going to be then referring to a solution as having a particular molarity. Now, solutions can be compared in terms of how much solute is dissolved in them, and that's called the tonicity of the solution. And I just want to introduce that word right now. So tonicity is a way of comparing or thinking about differences in the solute concentration of a number of different solutions. Now this will come up again when we get to our discussion of the cell and how the cell works with the different types of aqueous solutions that it has to interact with. But for right now, just be aware that when you see the word tonicity, or if you see the words hypertonic, hypotonic, isotonic, we're going to be using those words as a way to understand how much of a solute has been dissolved in a particular amount of solvent. Now, the way we're going to discuss it now, though, is in terms of molarity, the actual number of moles of a solute that are dissolved in a particular quantity of solvent. So let's talk about what a mole is. A mole is based on the molecular weight of a substance. Notice we're talking about the molecular weight of something. So the molecular weight is going to be the sum of the weights, the masses of all of the atoms that make up a particular molecule. And we're going to take a look at a couple examples so you can see what we're referring to. Let's consider CH4. That's 1 carbon and 4 hydrogens. It's a substance called methane. And we would say that that molecule has a molecular weight of, and notice what I'm using. I'm using the, right? Remember 12 was the atomic mass or atomic weight of carbon. 1, the atomic mass or the atomic weight of hydrogen. So that means that the entire molecule, CH4, would have a molecular weight of 16. And if we measure that in grams, we would say we have 1 mole of methane. By the way, moles are sometimes also called gram molecular weights. You can see where that comes from. It's the molecular weight of something measured in grams. Take a look at another example. This one's a little bit bigger molecule, and so as you might expect, we're going to have a higher gram molecular weight. A mole of glucose. So if I wanted to have 1 mole of glucose, I would need to figure out what's the molecular weight of this molecule. Well, carbon, 6 times 12, 72. Hydrogen, 12 times 1, 12. And oxygen, by the way, oxygen has a atomic mass and atomic weight of 16. So 6 times 16, and we have 96. The total mass of a glucose molecule would be 180. And if I measure that many grams of glucose, I would then say I have 1 mole of glucose. All right, so now, once again, a mole is the gram molecular weight of a particular substance. In the case of methane, we said that 16 grams of methane would be equal to 1 mole of methane. 180 grams of glucose would be equal to 1 mole of glucose. All right, so you see how it's based upon the total molecular weight of all of the atoms that make up that molecule. Okay? Now, 1 molar solution. If somebody said they had a 1 molar, and notice that's abbreviated by a capital M, a 1 molar solution of methane, that would mean that I've taken 16 grams of methane, 1 mole of methane, and I've dissolved it in 1 liter of water. So you could read that as 1 molar solution of methane. A 1 molar solution of methane. 1 mole dissolved in 1 liter. All right? So when you see the word molarity, or you see a solution being said to be a molar solution, you know that it's trying to describe to you how many moles of a substance have been dissolved in a liter of that solvent material. Now, if I had a 2 molar solution of methane, then that would be 32 grams. You get the relationship? If it's 2 molar, that means I have 2 moles of the substance dissolved in 1 liter of the solvent, water. If we did the same thing for our glucose molecule, we would need to take 180 grams of glucose, right? Remember, that was 1 mole of glucose, and dissolve that in 1 liter of water. And we would have a 1 molar glucose solution. So, remember what I said. I'm not going to worry about you being able to manipulate molarities and moles this semester. When you take chemistry, you will. When you take the A&P classes later in your program, you will. Then those qualities become more important. Now I'm just trying to expose you to the terminology so that when you see somebody talk about molarity, or you see a solution said to be a 1 molar or 2 molar solution, it won't be completely foreign to you. You'll have some sense of what they're talking about. Now, here's another interesting way we can talk about a mole, because we've discovered that when you have a mole of a substance, it's always equal to a certain number of the particles, the individual units of that substance. So, an additional way to define a mole is by using what's referred to as Avogadro's number. All right? So, Avogadro's number is 6.02 times 10 to the 23rd. A mole of any substance has that many individual particles of that substance in it. So if we go back to the things we talked about before, if we go back to our methane, right? Remember we said that a mole of methane would be 16 grams of methane. And you remember how we got that 16 grams. It was just the individual atomic masses of all the atoms in the methane. Well, here's the interesting thing. If I took those 16 grams of methane and I scattered them out on my desk and started to count them, and it would take me probably forever to do this, but if I counted them, I would find 6.02 times 10 to the 23rd methane molecules. If I took those 180 grams of glucose that we talked about as being equal to 1 mole of glucose, if I sat down and counted out those individual molecules found in that 1 mole of glucose, I would also find 6.02 times 10 to the 23rd individual glucose molecules. So that's another way that you'll see a mole described or defined. It will be a certain quantity of something that is equal to 6.02 times 10 to the 23rd of those things, whatever it might be. Okay? Just a very brief overview of this idea. That's all I wanted you to take from this, just so you would get a sense for how that word mole and the idea of molarity is being made use of. I might ask you an easy question on a quiz or a test about what a mole is, but it would be of the difficulty of the methane or the glucose that we just talked about. So take a look at some different molecules and see if you can figure out how much 1 mole would weigh. Oh, CO2, right? 1 carbon, 2 oxygens. Think about what the weight in grams would be that you'd have to weigh out to have 1 mole of CO2. So work on that. course, get in touch with me if you have any questions about it. But also remember that in this discussion we reiterated that idea that when we talk about solutions, we're talking about a solvent that a solute has been dissolved in. And one of the ways we try to describe the concentration of how much solute is dissolved in how much solvent is by using this idea of molarity. Okay, that's it. Don't worry about it too much. It was just to get you familiar with those ideas of a mole and molarity. And believe me, in your chemistry classes, you'll deal with this in much, much greater detail. Thanks very much. Talk to you later.